Alright, in this third trig video we finally introduced the trig functions. There are 6 of them. We're going to start out with the big 3 first, and then later on in the video I'll introduce the other 3. So here's the setup. Theta is an angle, it's in standard position. The terminal side intersects the circle at xy, and the radius is r. When we draw this, as I have in this picture right here, what we're concerned about is creating a right triangle. And so the way we create the right triangle is we go to the point xy and we drop vertically always to the x-axis, right? We never draw to the y-axis, and we make a right triangle. And we label the sides x, y, and r, because if the point is xy, that means we went x to the right and y up to get there. So with that set-up, then the definitions for the 3 trig functions are as follows. The cosine of an angle, abbreviated cos, C-O-S, theta, is equal to x over r, the ratio of the x side over the r side, the horizontal side over the radius. The sine of the angle, called sin, we pronounce it sine, not sin. Sine of theta is the y value, the vertical distance over the radius, and the tangent of theta, abbreviated tan theta, is the y value over the x value. And something to remember that will help you out later in trig is that the tangent is also the same as the slope of the radius. Okay, because you can see y over x is just a fancy name for rise over run. Okay, so there's our setup, and you're going to have a problem that looks like this. I'll tell you the terminal point, and I'll say terminal point is 512, and I want you to find the sine, the cosine, and the tangent of the angle formed when you have a terminal point at 512. So here's what you do. You start out by drawing the axes. You insert a circle, right? You approximate 512, and you'll notice this is not a unit circle. In fact, the radius turns out to be 13. Not all of our circles are unit circles. We'll find out later on that it's always easier to use a unit circle, but for right now, if the point is 512, then here's the angle in standard position. So I draw this, and here's theta, and then I'm going to go ahead and drop this down to make that right triangle. All right, so I hope you can see that the x value is 5, the y value is 12, and the Pythagorean triple tells us the radius is 13. And so you can therefore say that the cosine of theta, we don't know what theta is, the cosine is 5 over 13, the sine of theta is 12 over 13, and the tangent of theta is 12 over 5. All right, so one of the things we can do, given a terminal point, find the sine, cosine, and tangent. So now it's time to introduce the other 3 trig functions, and they are often called reciprocal functions. So let me go ahead and write the original. Cosine theta x over r, sine theta is y over r, and tan theta is y over x. So we have 3 more functions. As I said before, they're often referred to as reciprocal functions because they match up with each of these 3 and are simply the reciprocal of the sides. So the first one is the secant, S-E-C-A-N-T, and the abbreviation is SEC theta, and it's simply r over x. All right. The next one is called the cosecant of theta, and it is abbreviated CSC of theta, and that's going to be r over y. And then the last reciprocal function is the cotangent, and it's abbreviated COT theta, and it is x over y. Now this is important. I don't want you to memorize the x and the y and r and the positions for these 3. What's much more important is to know that the cosine and the secant go together, the sine and the cosecant go together, the tangent and the cotangent go together. And then once you find the cosine, you simply flip to find the secant. I hope that makes sense. All right, so let's go ahead and do one where we have to find all 6 of them. And here we go. going to word it a little bit because sometimes instead of giving you the terminal point, I give you a question like this. I say the cosine of theta is 24 over 25, and the terminal point is in quadrant 1. And your job is to find the 5 other trig functions. All right? So here's what you do. You draw your axes, you draw your circle, and you try to draw an angle in standard position where the x value is 24 and the radius is 25. It's a good idea to know ahead of time that y is going to be 7 from the Pythagorean triple, so that you can draw it so it looks kind of like a 24, 7, 25 triangle. Okay, it doesn't have to be perfect. The drawing there is just to help you find the other trig functions. All right, so now we have x is 24, y is 7, and r is 25. So that means that the sine of theta, I should put theta in there, the sine of theta is going to be 7 over 25. The tangent of theta is going to be 7 over 24. And then the secant of theta is going to be the reciprocal of the cosine, so that is 25 over 24. The cosecant of theta is going to be 25 over 7, and the cotangent of theta will be 24 over 7. All right, so those are the 6 trig functions. That's how we find them. Either I give you one and you find the other 5, or I give you the terminal point. Last thing I want to talk about before I finish this video is that there are some special angles that you've seen before that you do not need to know the terminal point, nor do you need to know one of the trig functions to find all 6 of them. It seems remarkable, but it is true. And so, I've got some stuff on here. I'll have to finish this. So here's what I'm talking about. If I want to find all 6 trig functions. So 6 trig functions for theta equals 45. And I don't give you a terminal point, all right? We go ahead and draw again, start out with the circle, draw the angle in standard position, label it 45 degrees, okay? Then we're going to go ahead and call this XY, drop this down to the x-axis, and this is the triangle I'm talking about. So I need the y value, the x value, and the r. And then we remember on a 45, 45, 90 triangle that whatever the x value is, the y value is also that value. So if this is x, this is x, and the r we can change to x root 2. So now to find the cosine of a 45 degree angle, we simply take the x value over the radius. Right? And that reduces to 1 over root 2. And so the cosine of a 45 degree angle is 1 over root 2. And this is kind of the amazing thing about trig. We're finding ratios of sides, and it doesn't matter what the radius of the circle is. It can be a radius of 100, a radius of 1. The cosine will always be 1 over root 2. And then for those of you who like to rationalize your denominators, that's what you get. All right, so the sine of a 45 turns out to be exactly the same thing because the x and the y values are the same. We end up with 1 over root 2, and the tangent of 45, because you're taking the y and dividing by the x and they are equal, the tangent is equal to 1. And that's kind of cool. Remember what I told you before about the slope, the tangent and the slope, that if you have a 45 degree angle, that radius has a slope of 1, and hopefully that makes sense. Okay, a lot of information. We're going to practice this in class. Next video we'll move out of the first quadrant. See you in class.